Hello, my name is Adrian Stevens, and in this video I hope to answer some questions which are motivated by my work as a Librivox volunteer. So how do you get a good recording that meets the Librivox standards? I hope to show you how various different types of microphone perform and how to handle noise in recordings and how to meet Librivox technical standards. In Librivox there is a process by which new people get to test their recording ability called the 1-minute test. As a volunteer I look at some of these tests and evaluate them and give feedback. And this video is in part motivated by wanting to describe the techniques used to combat the various failings that I see in recordings. You need to be wearing headphones to listen to this video because some of the effects I'll be describing require you to be able to separate signal and noise, and if you've got a lot of background noise at home or wherever you're listening to this, that might mask what I'm trying to show you. So let's start by showing some different microphones. This is called a lavalier microphone, also known as a tie-pin microphone. In France they don't use the word lavalier, which is strange. It's a clip-on microphone. There's a little condenser insert in there, and this one has a USB cable connection, so it plugs straight in your computer. This is a Sennheiser headset, and I'll be using this later for most of the recordings. It again has a USB connection, and on it, I'm not sure if it's written on it, but anyway, it describes itself as a noise reduction headset. And what that tells me is that the headset itself is doing some processing on the signal. Whether it's the kind of processing we like or we don't like, we'll find out later. Next is a microphone, again with USB connection. This one says it's Pro Sound. It could have almost any name on there. When you plug it in and look at the identification of this by Audacity, it's called a CUSB microphone, and that just relates to the manufacturer of the electronic chip that goes in here. This cost about $40, perhaps $30 on eBay. Just going back, this original one cost $15 on eBay. This headset, which I bought for work, about $45. And of course, in your laptop, you have a microphone. We'll test to see how well that works. You can't hard to put a price on that because obviously the laptop is going to cost hundreds of dollars. And here is what I use for regular recording for Librivox. This is a Blue Yeti microphone with a pop filter and stand. Let's bring you in close to look at this. It's mounted on a telescopic arm that is clamped to the side of my desk, and there's also a mount which isolates the vibrations of the table which would go up the stand from the microphone. So it's hanging upside down from that mount, and then in front of the microphone, separated by a small gap, is a pop filter which has been modified by being cut down and is tie wrapped to the noise stand. This shows my recording environment. I have a laptop here, I have a screen here, I have the microphone off to the side here. You'll note that the desk here is covered in carpet. The wall behind has a carpet draped from it, and there are carpets all around. And the fourth side, where the camera is currently, would normally have a carpet draped from that. And the purpose of the carpet is to reduce echoes and produce a dead sound. During this recording, you may hear me talk about signal and noise. Signal is just a word we use to describe what we want to hear, and noise is everything else. By analogy, if you imagine a garden and you're growing flowers, then the flowers are the stuff that you're trying to get, and weeds are stuff that grows up amongst them and you don't want. Definition of a weed is a flower growing in the wrong place. Well, it's similar with signal and noise. Signal is what you want, noise is what you don't want. And there are generally two sources of noise. There's environmental noise, and we'll listen to some examples of that later. Where I am, I'm sitting in a shed in the garden. It's currently raining. I can hear raindrops on the roof, which means you might be able to hear them too. I can hear a bird in the garden. I can hear traffic in the distance. These are all environmental noises. And then there's also electrical noise. If you have a cheap microphone, then it's most likely to suffer from two problems. One is the signal isn't very great. In this microphone here, it's a nice big, comfortable, big old-fashioned microphone, but actually inside it, looking through it, is quite a small insert. It's about, I don't know, half an inch, perhaps slightly larger. So this is actually a bit of a con. The whole thing could be a lot smaller and would have the same quality. And then the CUSB I've seen associated with various devices that all had a fairly high electrical noise. So you generally get what you pay for. And with the microphone here, it's a Blue Yeti. Pop filter, $15. Microphone, $70, reconditioned, second-hand. The noise isolation device here, about $40. The stand, about $20. So you can see the level of investment involved. And this produces the best sound of what I've got, because inside this microphone are three quite large inserts that are combined through the electronics, and it's high-quality electronics as well. So this produces the lowest noise, but it's not zero noise, and we'll listen to the kind of noise it produces later. I'll give you some idea of the environment of my recording booth. This is actually a shed in the garden. So there's my recording setup, and I've got the usual junk that you get in a shed. I have an exercise machine, and I have my electronic store cables and then crates with various bits of junk in. I have other stuff in here which is not related to Audacity. And we'll go outside, and you see it's actually snowing at the moment. And that's my shed in the garden. This is my workstation in the house. I don't use the house for recording for two reasons. One is that there is environmental noise from washing machines and the cat eating his whatever he's eating. Also, the acoustics in here are quite echoey because we have a hard floor, a hard ceiling and hard walls, and so you'll hear a bit of an echo. I've got a reasonable mic, which is a Samsung Go mic. This is a Samsung Go mic on a homemade boom, which sits a few inches in front of my face. I'll occasionally do a correction if I'm editing and pop in the odd word here, and you probably don't notice it, but on a longer recording you'll notice the harder acoustic. We're now in the house, and we're going to look at the recordings that we just made. I've opened up Audacity. This is version 2.3.2, and we have all of the various recordings that we've made here. Let's listen to the recordings and evaluate their quality. I'm going to hit the solo button, and you'll note that the display I've selected is Waveform DB. This enables you to focus on the noise component. If I switch to Waveform UnDB, you see that it hides what's going on in the noise level. So let's move back to Waveform DB where we can see the noise. Let's listen to this track.
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
And looking on the screen, you can see the relative levels of the noise and the signal. Now we can select part of the noise with the mouse, and if I do Effect Normalize, what we do is bring the level up to a constant maximum level, so it amplifies it as much as it can without introducing clipping. Let's listen to see what's going on in the noise. So what you're actually hearing there is the sound of raindrops on the roof of my shed. That's the pitter-pattering noise. There's also works going on in the field behind my house, so you can hear the engine of whatever is operating out there, and towards the end you can hear a bird. Listen again. What you're not hearing is a lot of hiss, and this tells you that the quality of the electronics is very good, and that the noise you're hearing is essentially environment, noise from the environment, not noise introduced by the electronics itself. Now let's go to the next track. The next one was recorded on the Pro Sound. When I said C-USB, it's actually C-Media is the name of the chip. So I hit the solo button, and the first thing you can see is that the 0 is offset. So to get rid of that offset, which distorts our view of the world, we'll do Effect Normalize, and this will remove the DC offset. Now this looks a bit like the previous one. Let's listen to this.
Pro Sound, C-Media USB microphone, held to the side of my face about 4 inches away. Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
To my ears, that is a high quality recording. I don't hear any distortion in the recording itself. You can see visually that the noise is more than in the Blue Yeti case. Let's listen to the noise and see whether it's environmental or electrical. I'll normalize it and then we can play it. You can hear the pitter-pattering of the raindrops, but they're a lot less than the level of the noise. So what you're hearing now is largely noise generated inside the microphone electronics itself. Let's go on to the next microphone. This is a Sennheiser, the noise-reducing headset, the one that I'm wearing at the moment for recording this narration. Let's listen to it. This is the Sennheiser headset microphone. Record volume is full up.
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit ditties of no tone. To my ear, that sounds as if it's been processed. It's lost something. It's lost kind of immediacy or liveliness. I think it's also lost bass. Let's listen to what the noise is. Effect, normalize, play that. So there you can hear the pitter-pattering of the raindrops, perhaps slightly stronger than in the ProSound case, which means that the electrical noise that it's introducing is less. But however, there's something new here. Listen again. I don't know if you can hear a high-pitched whine. To my ears, there is a high-pitched whine in that signal that wasn't present in any of the previous recordings. Now we can use the tools that Audacity gives to analyze that. So if we do analyze plot spectrum, what we see is a curve corresponding to the kind of noise. If this was a pure noise, you'd just expect a smooth curve, but we're seeing a bump at around 1000 Hertz. And that is coming from the electronic circuitry somewhere. So normally that's below the level of audibility, but when you normalize just the noise, you hear that slight electrical interference. Let's undo that and move on to the next microphone. This is the USB lavalier. Now the first thing to notice is that the level recorded is lower. Now the microphone record level's up to max, so I couldn't do anything more with the recording. Let's normalize this in Audacity so that it's at a similar level to the previous recordings, and immediately you do that, you notice that the noise jumps up. So even before we play this, we're expecting to be able to hear this noise.
This is the AK5371 lavalier USB microphone by Givasler. Again, the recording level is up to the max. Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit ditties of no tone.
I would say that I could clearly hear the background behind that. If somebody submitted this as a Librivox recording, they may well get a comment that the background noise was excessive. I think I would make that comment if somebody submitted this and I was checking that recording. Let's listen to what the noise sounds like. Let's equalize the noise. Sorry, normalize the noise. So we're hearing the pitter-patter, I think, louder than in the Sennheiser case, so that tells me that actually the noise level is relatively less than in the Sennheiser case. But the whine in this is more pronounced. Listen again. Let's use the Audacity tool to plot spectrum, and we're also seeing a spike at roughly 1000 Hertz. That's probably coincidental. We're seeing it at 1000, 3000, sorry, 2000, 3000, 4000, 5, and so on. And so we're seeing an interference signal at about 1000 Hertz plus its harmonics. Now let's go on and listen to the laptop microphone.
And this is...
That's a bit quiet, so let's equalize it. I mean normalize it. Or perhaps it's just marmalize it. Okay.
And this is the microphone array Realtek High Definition built into my ThinkPad X1 Carbon laptop. Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
To my ear, that has a processed quality to it. If we look at the screen, we can see that the noise level is low. It's lower than even the very good microphone, the Blue Yeti. But they've achieved that low noise level by processing the signal. And to my ear, the processing has again lost the liveness of the signal, it's lost the bass. Listen again to some of this.
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
If somebody submitted this as a Librivox recording, I would pass it, but I would note to myself I didn't like it because of its process character. I think finally, let's listen to the effect of near and far recordings. So I'm going to take this track and normalize the entire track.
Testing, 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 testing. 1, 2, 3, 4. This is close up.
And now I move away from the microphone.
Speaking, testing, 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 testing. 1, 2, 3, 4. This is quite far away.
And it's a no-brainer that the signal is going to get less. So let's amplify just the far portion of this. So now the signals should have the same amplitude. But you'll notice in the background, if I blow this up a bit more, that the noise between these words is higher because obviously we've amplified both the signal and the noise. Let's listen to both of these together.
Testing, 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 testing. 1, 2, 3, 4. This is close up.
Speaking, testing, 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 testing. 1, 2, 3, 4. This is quite far away.
And there we're hearing the effect of the environmental noise. So we can hear the hum from the engines, we can hear the pitter-patter of raindrops on the roof, none of which we heard in the first recording. So again, listen to both of them, looking for both of those effects.
Testing, 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 testing. 1, 2, 3, 4. This is close up.
Speaking, testing, 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 testing. 1, 2, 3, 4. This is quite far away.
I was about 6 feet away from the microphone in that case, and clearly unless you're in a very quiet environment, you're going to hear the noise from the environment, but also you're hearing the echo from the room. So although I've got blankets hung on the walls of my little recording cube, the side was open to the rest of the shed, and I was out in that part of the shed where it was all echoing. Now let's talk about noise reduction. Looking at the very clean recording I have, we have a period of relative quiet. I'm going to select what appears to be a constant part of this and do effect, normalize, sorry, not normalize, effect noise reduction. We do get noise profile, then we do effect noise reduction. Oh, before I do that I have to select the entire track, which I'm doing by clicking in this part here, then effect noise reduction, and I'm going to give it 12 dBs, which is what I would normally give it. What you have in this dialog here, you have three parameters. Sensitivity and frequency are both set to 6, as in the Librivox recommendations, and I don't really know what effect these parameters have. I know what effect this have. This is the amount of noise reduction. So let's click on 12 and you can see it has reduced the noise there to a very low level. And if I play some of this,
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on.
that still sounds good to me. I can't hear any negative effect from having done the noise reduction. But let's come down to the noisy USB lavalier and do noise reduction here. So I'm going to get the noise profile, and I'm going to apply 12 dBs of noise reduction. Let's see what happens.
5371 Lavalier USB microphone by Givasler. Again, the recording level is up to the max. Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
Now, to my ear, I can just about hear the whine, the electrical whine in the background there. I'm not sure I'm hearing the hiss. I'm not hearing the raindrops. The quality of the speech that I'm hearing is distorted. I can hear that it's processed, and although this is the same amount of noise reduction as in the Blue Yeti case, here it has to remove a lot more signal because the noise is much higher in amplitude, and that explains why when it gets it slightly wrong, it's reducing a slightly wrong amount of a much bigger signal, and that's what creates the distortion. Just for illustration, if we try and get rid of the noise altogether, let's do say let's give it the maximum. We can give it 48 dBs. Let's see what this does. You see it removes the noise altogether. Let's listen to this.
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
Now that background whine has completely disappeared. You can see that the background noise is completely gone, but we've lost the quality of the speech. It sounds highly processed to me, and in fact this is reminiscent to me of the laptop speaker recording, laptop microphone recording. If we go back to the Blue Yeti case and do noise reduction on this to completely remove the noise, what effect will this have on the signal? Let's give it, say, 24. And you can see now, apart from a few spikes, we've got rid of all of the noise. Let's listen to it.
Heard melodies are sweet, but those unheard are sweeter. Therefore, ye soft pipes, play on, not to the sensual ear, but, more endeared, pipe to the spirit, ditties of no tone.
Let's undo that and replay that to the original.
Heard melodies are sweet, but those unheard are sweeter.
See, to my ear, I don't really hear much of a difference between those. So we were able to get rid of the very small amount of noise that was still remaining without really affecting the speech. And I guess the to summarise this, it's a case of garbage in, garbage out. If you start with a good clean signal, you can clean it up further. If you start with a signal that is originally very noisy, there's no magic wand. You can't get rid of that noise without distorting the sound of the wanted signal. So what are the Librivox standards for recorded speech? Let's close this and record a section and indicate what, and then save it and then check it. So the question is, what parameters do we need to ensure that we meet the Librivox standards? For the first thing you need to do is to set the project sampling rate. In Librivox it's 44/100 Hz. Once you set that, you shouldn't need to change it. Then we're going to do a recording. I'm going to record from the Samsung Go mic, which is sitting on a boom just near my face. And I'm going to hit the start monitoring and check that the volume level is okay. It comes to about -12 dBs, which is where I like it to be. So that's absolutely fine. Then I hit the record button and we'll record. 'Twas brillig, and the slivy toes did gyre and gimble in the wabe, all mimsy were the borogoves, and the mome raths outgrabe. Okay, we'll stop that. And this is our recording. You could see that there's some level of noise. Let's just normalize this to see if the noise is audible or not.
'Twas brillig, and the slivy toes did gyre and gimble in the wabe, all mimsy were the borogoves, and the mome raths outgrabe.
Let's blow up some of that noise to see what it's composed of. Play this. That seems to be mainly electrical, a kind of hissing sound. However, there is a computer fan going down there, which I can hear with my ears, so that's probably mixed in with it too. I'd say the noise is just about audible. It's not distracting. I personally would never send in a recording like this, so I would do noise reduction on it. I get the noise profile, select all the track noise reduction. I'll give it a moderate amount, 12. So that knocks the noise down and shouldn't distort the speech.
'Twas brillig, and the slivy toes did gyre and gimble in the wabe, all mimsy were the borogoves, and the mome raths outgrabe.
Okay, so I think that noise has now got to a level where nobody's going to notice it if they listen to this. So to make this ready for Librivox, I'm going to clear, that was Control-L on the keypad. We need approximately 5 seconds of run out, which should take us to 16-ish. So I'll just trim a little bit off there. Going to the beginning, I'm just going to clear this, Control-L, and then delete everything but half a second. So we've got half a second of run in, 5 seconds of run out, and finally I'm going to apply a plugin called Replay Gain. Again, I'll leave a link to this in the description. This will adjust the volume so that it meets the Librivox expectations. And you can see it actually reduced the volume there slightly. Okay, so now we're going to export this to MP3. What we do is File, Export as MP3. We're going to call it Test Recording 2 for no particularly good reason. These settings are important. So you need constant bitrate, You need quality is 128 kilobits. You also need force export to mono if you record it in stereo. If you record it in mono, it has no effect. And hit the save button. Then what we're going to do is look at this recording. So I bring test recording 2 into a program called Checker, which is going to check that it meets the Librivox standards. I'll leave a link to this program you can download and check your own files. And this tells us about this. Firstly, it passed the checks. It gives us the format 128 kilobits per second, 44,100 Hertz, mono. The volume is 88 dBs. That is within a range of 86 to 92 dBs that is acceptable. DC bias is very low. There's no clipped audio. Background noise is a measure of the background noise, which it says is 24.2 dBs. In practice, this is what the tool gives you if you clear the remaining part of the recording. So this is an acceptable recording, and you could upload this and expect it won't fail on technical grounds.
Thank you for watching. If you have any ideas for future videos on things like signal and noise and the mathematical relationship of these, or the use of the Librivox forums, or why I personally enjoy contributing to Librivox and the type of readings I enjoy doing, then please leave comments. If you liked it, please comment. If you hated it, give me a thumbs down. Goodbye.